Okay, in this video I wanted to review a problem for exam 2, and part of my motivation for that is when I made up the problem for your homework set, I actually messed up one of the loops. You can't just arbitrarily put together a circuit like this. All the loops have to sum to 0, and one of the loops in the problem that I put together did not. And so depending on how you navigate through the path of that solution, you get inconsistent results because it wasn't really a valid circuit. All right, so what I wanted to do is just kind of toss that out and go through a solution to a problem like this that is a valid circuit. Okay, so here's the problem. We have connected elements, and what we know is a few of the currents. We don't know all the currents, and we don't know all the voltages. All right, but what we want to do is figure out the power used by each element, and then verify that we have conservation of power. All right, so let's get started. All right, so I'm looking at this circuit, and what I'm seeing here is that I don't know VB. All right, so here's VB, I don't know that. And I don't know VC. I'm also wondering about the current through branch, the branch that has element B in it. All right, so this current and this current, those are unknown currents. All right, so let's take care of the currents first because those are pretty easy. All right, so if this is 9 amps coming around this way, all right, and 4 amps leaves this way, then that leaves us 9 going in, and we'll call this IB. IB going out, and 4 going out. So we solve, we get IB is equal to 5. All right, so easy enough. All right, and then at this node, we have 5 coming in, we got 2 going out, and then if I call this IC coming down, we have IC. All right, so IC is equal to 3. Okay, good. So now we have the currents. Now we need to solve for the voltages. All right, and so the voltage loops that I'm going to use, I'm going to solve for VC first. I'm going to start down here at this corner and go around this way. All right, like that. Okay, so when I do that, I get a rise of VC is equal to a drop of 15. All right, do you see that? Rise of VC, drop of 15. All right, so VC is 15 volts. Easy enough. All right. Looking at this, what else do I not know? I don't know VB. All right, so I write a loop equation. Again, this starts to get pretty messy when I leave all the notes on here. But I'm going to start right here, and I'm going to go through all the things that I know, right? I know that. I know all the voltages in this path except for VB. All right, so when I do that, I get a rise of VB is equal to a drop of 10 plus a drop of 15 plus a drop of 5 plus another drop of 15. So VB is 45 volts. Okay, and then finally VG. When I initially identified the unknowns, I didn't see that one. Okay, so we also got to get VG. All right, so I'm going to go, you can go in different directions. I'm going to go this way, just for grins. Okay. All right, so if I go in that direction, that would give me a rise of VG is equal to a drop of 5 plus a drop of 15. So VG is 20 volts. Okay, so good. Let's mark these on the diagram. VB is 45 and VC is 15. All right, from there, all right, let's clean this up a little bit. From there, I can calculate the power associated with each element. Okay, so let's look at element A. All right, so with element A, I have power is V times I. V is 5. I is 5 going through element A. V is 10. So I know this is 50 watts. And current's moving in the direction of a voltage drop. So this is the passive sign convention, so this is using power. All right. For B, we have 45 times 5. Okay, so 45 times 5 is 225 watts. Okay. Current is moving in the direction of a rise for B. So from, I go in this direction with current. It's 5 amps. From the minus to the plus, so it's a voltage rise. So this is the active sign convention. So the power in this case for element B is 225 watts supplied. Okay, moving on quickly to element C. Element C, I have 3 amps moving down in the direction of a drop. 15 times 3 is 45. So it's the passive sign convention, so it's used. Element D, 15 times 2, in the current's moving in the direction of a drop, that's the passive sign convention, so that'd be 15 times 2 is 30 watts. Keep putting an extra tail on the W there. Used. Element E. Okay, so for element E, I've got 4 amps showing. 4 times 15, so that's 60 watts. This is in the direction of a voltage rise, so this would be supplied. Element F, 5 volts. Current moves in the direction of a rise. It's the active sign convention, 20 watts supplied. And finally, element G. Element G we know is 20 volts. This is the current of 9 amps, so 20 times 9 is 180. We have 180 watts. Current's moving in the direction of a drop, so this is used. All right. So we do some verification. At the end, it should line up so that if I sum all the things that are used, it equals to those that are supplied. All right, so I'll put those in purple. Okay, so I think this checks out, and so this, hopefully you know how to do this. This is going to show up on exam 2.